f of x equals this piecewise function. Okay, my job is to make sure I find out the limit as x approaches -1. Now, looks like my piecewise function splits here at -1, but this is what I have to keep in mind. I'm not going to just plug in -1 and plug it into this guy right here thinking, oh, it's or equal to, it's fine. This is an idea of we have a piecewise function and something like this could happen. Okay, and if we're trying to find the limit as x approaches a number, we need to make sure that the left side and the right side are exactly the same. And I don't know if that's the case yet. So what I have to do is I have to plug in -1 for both of these and see if I get the same number. If I do, then that means the left side and the right side actually approach the same thing, so something like this happens. And if that's the case, then I have an answer. If they don't approach the same thing, the limit does not exist. But if they do approach the same thing, it does exist, and it exists at the number that I get. So what I'm going to do is I'm going to do this first equation. I'm going to plug in -1. So ln of -1 plus 2 is the same thing as ln of 1, and ln of 1 is 0. Okay, the ln or the log of 1 is always going to be 0 no matter what log it is. It's just the way that exponents work because, that's just the way exponents work. So you get 0. So this guy gave you 0. Let's see what this guy is going to give you. So if I were to plug in -1, I would have -1 cubed plus 2 times -1 squared minus 5 times -1. -1 cubed is -1. -1 squared is +1 plus 2, or times 2 rather, so 1 times 2 is plus 2, and then minus 5 times -1 is going to be plus 5. -1 plus 2 plus 5 is not 0. In fact, it's 6. So since these guys are different numbers, we have one of these right here. So since the left-handed limit and the right-handed limit don't meet at the same place, then the limit at the regular number itself does not exist. Okay, so it was kind of a tricky problem, but we did it.